So after 59th question, we have question number 60, 61, which is related to graph that I will take up after I finish the remaining numerical problems. So right now I am in 62nd question. The question is, a car moves linearly with uniform retardation. If the car covers 40 meters in the last 2 seconds of its motion, what is the velocity of the car at the beginning of the last second? So as per 40 meters in the last 2 seconds, we are supposed to find the velocity of the body in the last 1 second of its motion. That means this is the retardation part. The body is in uniform retardation. If it is in uniform retardation, then in 2 seconds, if the body travels 40 meters, in the first second it should travel at 20 meters, and in the next second it should travel at 20 meters before finally the body comes to rest. We are supposed to find the velocity of the car in the last 1 second of its retardation. So this 20 meters, the body travels in just 1 second, and this is the previous second duration or distance. So we are supposed to find the velocity of the car in the last 1 second. So in the last 1 second, the velocity the car acquired. So we are supposed to find u. So first what we'll do is, in the last 1 second, because the body is in uniform retardation, 40 meters in 2 seconds, then every 1 second, the body must have covered 20 meters. So we will use v square minus u square is a 2as for the last 1 second of its motion. So final velocity is 0. So u square, this is our requirement. This is twice. A has to be negative, but we want that. Distance is a 20 meters a distance. So here acceleration is minus u square by 40. So this is the retardation with which the car travels in the last 1 second. Now distance traveled by the body in nth second is given by u plus a by 2 times twice n minus 1. Since we have to find the velocity of the body in last 1 second, we are using this formula. So distance traveled in the last second is 20 meters. Velocity in the last 1 second is our requirement, plus half. Acceleration in the last 1 second is this. So I am using minus u square by 40. So last 1 second, so 2 into 1 is a 2, 2 minus 1 is 1. So ultimately we are getting 20 is a u, plus of minus is minus u square by 80. Now multiplying throughout by 80, we will get 1600, 8 2 is 1600 is 80 u minus u square. Putting this in standard form, bring these two to the next side, transposing, we will get u square minus 80u plus 1600 is 0. And we got a standard form of a quadratic equation. And once we solve this equation, we will get u, which is the requirement. So I am going to use the quadratic formula. For that, first we will use the discriminant formula. Discriminant is b square minus 4ac. b square means minus 80 square. So negative square is positive, 8 square is 64, 6400. So 6400 minus 4 times a is 1. Coefficient of u square is a, which is 1. C is a 1600. So this is 1600. 16 fours is 64. So this is also 64. So discriminant is a 0. That would mean that this is a perfect square. So we can find u value. U is minus b by twice a, since a discriminant has turned 0. So initial velocity in the last 1 second of its motion is minus of b is minus 80. So I am writing here minus 80 by twice A. A is 1. So initial velocity is minus of minus plus 80 by 2 is 40. So 40 meter per second is the initial velocity in the last 1 second of the retardation.